Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue looking at recursion and uses of recursion. In particular, we're looking at recursion that calls itself multiple times. In the last video we looked at Fibonacci numbers. We saw they're a very simple example of this. And in this video we're going to look at generating permutations. Now, there is a standard API call for generating permutations on a sequence. And in fact, it's really what you should wind up doing, because when you do permutations, there's lots of possibilities. For this, we're going to write our own, because it's a good example of a recursive call that calls itself not just 2 times or 3 times, but potentially many, many times. So we'll go and start a new file for this. And the idea here, okay, so let's say I want to do this with, well, we can do it with an array or with a list. We could actually do it more generally with a sequence. So let's just go ahead and say we're going to do this on a list. And I'm going to make it a list of integers, because they're very easy for me to type in. And what this is supposed to give us back is a list of integers. Okay. And so it's going to give us back a list of all the permutations of this. So in case you don't remember what permutations are, they are all the different orderings that you can have for something. So for example, if we had the values 1, 2, 3, 4, well, that is one of the permutations on it. Another one would be 1, 2, 4, 3. Another one is 1, 3, 2, 4. Another one is 1, 3, 3, 4, 2. And then we can repeat all of these with things other than the 1 in the first position. It turns out, like I said, there are quite a few of these. How many of them are there? Well, it turns out that there are n factorial. If you have n elements in here, there are n factorial permutations. So if I'm going to generate this as a list, this is something that you don't really want to do for a long list. You'll wind up consuming the entire memory on your computer if you do so. But let's think about how we would do this. Okay, so if I give you a list like 1, 2, 3, 4, the idea is that first you pick one of these elements to be the first element in your permutation. So I would do all the permutations that start with a 1 and end with some permutation of 2, 3, and 4. So notice that we're defining permutations in terms of permutations. You pick one element out, and then you make new values that are that element at the front of all the other elements that would come after it. Okay, and so that's what we want. That's what we want to do for this code. So how do we do that? Well, we need to run through all of the elements that are in our list, LST. Oh, well, actually, let's start with our base case. If, you know what, I feel like doing this using a match statement. So one case would be you give me the empty list, in which case the list of permutations on the empty list is, well, there are no permutations on the empty list. Well, I guess there is one. It's the list of nil. What if you get a list that has just a single element in it? Well, once again, there's only one permutation of that, and that is the list itself. If I give you anything else, so yeah, anything that's not empty and it's not a list of one element, then what we need to do is we need to run through every single element that is in the list and build permutations off of it. So I want to run through each one of the values in this list, and I'm going to do this as indices. So I'm going to go use the list.indices. That gives me back a range, and it happens to have the valid indexes that I can use in this. And I want this to yield a value for me. There's a part of, well, we'll come back and deal with the nuances of this later. So, okay, so this is going to run through every index. It's going to start at 0. So up here it starts 0, 1, 2, 3. This only has 4 elements in it, so the indexes go from 0 to 3. And for each one, what I want to do is pull out one element and then take that element, and I'm going to cons it onto all of the permutations that we get from everything after that. So how do we get the element? Well, in some ways that's easy. You know, the fact that I'm pulling out elements of a list using this does make me feel like perhaps I should be doing this with an array, but you know, those are issues. It turns out the way this is working, we're going to be rebuilding so many lists, and if we were using arrays, we'd be rebuilding so many arrays. I'd actually want to do performance testing to really know what the ideal approach would be. So I pull out the ith element from it, and then I'm going to, I need a list of everything except for that ith element. Now it might be tempting to try to use like a filter to pull out elem, but then you have the problem, well, what if that element occurs more than once in here? I don't want to remove all instances of that element, so instead I am going to make a call to split at, and I'm going to split at I. And let's remind ourselves what split at I does by pulling up the RAPL. So if I have a list like this, and if I split at element 2, that's the index of the 3. So what I get is I get the stuff before that index, and then I get the rest of it, that index and everything else. Okay, so turns out in fact here, let's go ahead. There's another way to get hold of the element that we want at the ith index there. So we split at the index. That gives us back everything before that index as well as that index plus everything after it. We pull off the head of the rest, and that gives us this. And now I'm going to make a variable, call it subpermutes. This is the this is going to be a list of events that are all the permutations of everything except for this element. So it's a recursive call. So I'm going to call permutations on before and rest.tail. Okay. I don't want to keep the entire rest. I want to throw away that. Notice that both of these are lists. I could use the triple colon cons. The plus plus works for all collections, so if I decide later I want to change this so it's not a list and instead like it's an array or something, this operator will continue to work there. And then what I want to yield back is all of the elements, or all of the values that are in this with elem appended onto the front of them. So I want to give back a sub permutes mapped so that I get elem cons that permutation. Okay. Now, let's try this. I've written enough code that I should see if it compiles, see what syntax errors we have. Okay. Yep, indeed. Here's one. This is a type error. We have a nice syntax error there. This has to return a list events. LST is only a list event, so I need to put a list around that so that I have a list of all the permutations. Of course, there's only one permutation in there. Okay. Next error. Not found value permutations. That's an interesting question. I'll make them both plural. Doesn't matter which I choose, but I do have to make it so that they're in agreement. This one here and this one here didn't agree. Type mismatch. Okay, now this is the error that I was waiting for us to get. Right now, this does not yield a list of ints, and one of the problems is that when I take a range and I do a yield over a range, I don't get back a list. Well, that would fix that, but it doesn't actually fix our problem, because what we're getting back is a list event, and we only want a list of ints. Okay, so how do we deal with this? One thing, I'm only slightly worried about how far that will go. Okay. One approach is to call flatten. So you might wonder, what the heck does flatten do? So let's say I make a list. It is a list 1, 2, 3, list 4, 5, 6, and I flatten it. Well, what it does is it takes each of the lists inside and makes them just elements in a new list that's built out of them, which is exactly what we wanted. It kind of flattens out this layer in there so that instead of having a list of events, we just have the list of events, which is what we want. Next up, let's see if this actually works. And I'm going to call this first on just the list 1, 2, 3. So we get 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. As I said earlier, there should be n factorial. Here n is 3, 3 factorial is 6, and indeed there are 1, 2, 3, 4, 5, 6 values inside of there. If we were to do this and add a 4, now I have quite a few more options, because now we've gone up to 24 possibilities. If I were to add 5, we'd have 120 possibilities in here. But this is some simple code to generate permutations. Something that you should notice if you have gone through the book to look at this is inevitably this code is different from what appears in the book. Any piece of code that you write can be written in many, many different ways. Inevitably, some are preferable to others. This is, as I promised when the introduction to these videos, this is a live coding thing. I'm largely generating this off the top of my head. There are inevitably some nuances to this. It turns out that a lot of people if you want to use much more of a normal Scala style, instead of flattening this, you would use a for comprehension in here. I don't know if that's exactly the approach. That's not really the approach that I've taken so far in this book, but it's something that you might want to go out and look at. Remember, you can put val declarations inside of for loops, so it turns out that I can have not just this, but also this and this and this all inside of the for loop, and then this line becomes another generator in there. And so feel free to spend some time changing it so this code doesn't use the flatten, and instead all of this is inside of the for loop, so that after the yield all you have is element cons something, something that you have to give a variable name to. But that's it for this video. This was once again a look at a recursive function that calls itself many times. This recursive call right here doesn't just happen once or twice or 3 times. It happens as many times as there are elements in this list. So if we did give it, in our case here, we gave it a list with 4 elements. So at the top level it calls itself 4 times. Each one of those calls itself 3 times. Each one of those calls itself 2 times. And then it hits this situation and they all jump back out. But that's it for this example. And we'll come and look at another example of recursive functions that call them